Welcome back, engineers, to 3.2.1, which is Introduction to Fluid Power. And this is part 2. So part 1, we got a little introduction to fluids, how they're a gas or a liquid. And if you use the liquid, that's called hydraulics. And if you use gas, that's called pneumatics. We got a little introduction to kind of how work is calculated. It's force times distance. And then if you take force times distance divided by time, that's power. We got an introduction to fluid power systems, pumps, tubes, pressure, valves, and then we did an example. We looked at how gear pumps work. So we're going to take off today talking about some more things with fluid power. So the actuator volume. So what they're saying here is the volume displacement is directly affects the speed. So if you want an actuator to go fast, a smaller volume is needed. The bigger the actuator, the faster you have to pump it to make it go out. So maybe you have like, I need to go 2 feet in 1 second. But the question is, how much volume do you have to fill to make that actuator go forward? The less volume that you need to displace, the faster this actuator is going to be. So check this out. I always, when I was a kid, they always had me running the log splitter for my family, and I always noticed that the actuator, the log splitter, it would go backwards faster than it would go forward. And this makes perfect sense because if you look at this, it has to fill more volume over here to make this actuator go forward. When you fill it up on this side, this tube is in the way, so it has to fill up less volume. So a hydraulic and pneumatic actuator, they're going to go backwards faster than they go forwards always. They will always retract faster than they go forward. You could maybe build in electronics to like limit that, to like reduce your flow. If you want to make them go the same speed, you could reduce your flow while you're retracting and then increase your flow while you're extending. Pressure. How much pressure depends on its force over area. So inside of a system, all points are experiencing what's called the same pressure. The farther down the line you have, the less pressure because of just losses. Or if you've got a kink in the pipe, you're going to have more pressure in front of it than in front and behind it. Pressure is force divided by area. So this is called Pascal's law. So if you put in 10 pounds over 20 square inches, pounds per square inch, 10 divided by 20 is 0.5. So what that means is if you're pushing down on this stopper right here with a force of 10 pounds, that means that on every square inch of that outside, there's going to be 10 divided by 20 or 0.5 pounds per square inch. On every square inch, there's half of a pound of force. Fluid power principles. Hydraulic press. Could you take 10 pounds and lift 100 pounds? Like it's like a simple machine. Could I lift a 100-pound mass with 10 pounds? Yeah, you could use a lever. You could use any of the simple machines if you had the right mechanical advantage. And that's what we're going to be having here. So this 10 pounds can lift this, but again, the trade-off is distance, right? So you push down on this. You're going to push this 10 pound, you're going to push this 10 feet, but you're going to make this thing only go up 1 foot. That's if it's 100% efficient. You're going to have a trade-off. If you're going to use 1/10 the force, you're going to have to use 10 times the distance to make this work, assuming it's 100% efficient. We get into some schematics here. I gave you a little introduction to that on part 1, but we'll get into more of it right now. The symbols. Basic symbols, circle, squares, arcs, dots, crosses, triangles. If you've got a pipe that contains fluid, Solid line, a dashed line, it means something. A flexible line, you can have like a droop right there. If your lines, they have to cross each other on the schematic, but you don't want them to actually be hooked up together, you could either jump them or you can connect them with not a dot. But if the lines are supposed to be connected, you put a dot in there. If you have a filter, we kind of showed you that last time. This is what a filter looks like. Reservoirs, you saw in that first one, it was just a tank, or you can physically draw like a pressurized tank so you can push it. Here's a return line. So, and then it fills it from the top, or you can fill it from the bottom. Your pump, the arrow always represents the direction that the fluid flows. So pumps, this is going to push up. A variable, so if you want to be able to increase or decrease your flow rate, you can draw a diagonal line. So a pressure compensated pump, so here's a pressure relief valve. So if you want it to have certain amounts of pressure, and if it goes over, you don't want too much pressure, you can have like a spring. That's a schematic for that. Your valves, flow control, so you can have a fixed orifice, a variable, and that you'll see that happen a lot. If there's a diagonal arrow, it kind of means that things are adjustable. And then here's a check valve down there. You'll see those coming up. Your directional control valves, in part 1, I kind of showed you how those things look. And so this was the one that we had before. So normally it would just return, but if you push it to the right and you push it to the left, it switches. So these are different symbols. Here's a spring return. So this right here, you could have a spring operated, or you could have a mechanical, like with our can crusher that I have next door. I have, it's an electronic, a solenoid, so you can use electricity to push that thing, so you can send a signal from your cortex to operate your hydraulics. Check valves, they only let fluid flow in one direction. So if you only want something to go one way, you have the arrow. It says that the fluid can go from left to right over here. Motors, 2 arrows mean you can turn them forward or backwards. Here's a drain to a reservoir, so you kind of see how these things are hooked together with our dash line meaning a drain line, and then this is the reservoir. Our cylinders, so if you want your cylinder to only go one direction, sometimes they have a spring inside of here, so the spring will return it. Or if you want it to go both ways, or if you want it like double rod. So this is actually how your steering wheel works on your car. When you turn a wheel, you're pushing fluid, and this is why we call it power steering, because there's hydraulic fluid being pushed in through a real special valve that your steering wheel works to turn your wheels. So this valve goes left and right to turn your wheels. Maybe you want it to be a bumper so that when the thing goes out, it doesn't like bang. It wants like a cushioned blow. And then if you've got a larger diameter rod or cylinder, you can actually show that in your schematic with the picture. That's all. Part 2 of hydraulics.